In this portion of the lecture, we'll begin looking at the history of payment systems that were invented prior to Bitcoin. We're going to start by looking at credit-based systems. In general, what you can do is you can take all the systems and sort them into two piles. There's pile based on credit systems and there's piles based on cash systems. Bitcoin obviously is in the pile of cash systems. However, we should also look at credit-based systems, even though Bitcoin's not part of that pile, because these are the systems that are competing with Bitcoin. Credit card transactions are the dominant payment method that is used on the web today. If you've ever bought something from a website such as Amazon, you know how the arrangement goes. You type in your credit card details, you send it to Amazon, and then Amazon turns around with these credit card details and they talk to the system, the financial system. We don't have to go into all the details of who the parties are that are involved in the financial system, but in general, there's a credit card processor, and the credit card processor is going to talk to the banks, the credit card companies, and other intermediaries. The other architecture that you may see if you use something like PayPal is an intermediary architecture. In this case, there's a company that sits between you and the website. So you send your credit card details to this company, it approves the transaction and settles with the website. The advantages of this type of architecture are privacy. In this case, the user is never fully disclosing all their credit card details to the website. The drawback is that the user is no longer directly interacting with the website alone. The user has to interact with this intermediary. They have to be aware that the intermediary exists. They may have to have an account with the intermediary. Now, an early system to use this type of architecture was a company called First Virtual. It was founded in 1994. First Virtual is an interesting company because beyond just being one of the earliest players in doing electronic payments, they were also one of the earliest companies to try and set up a virtual office, as it was called. And that's why they called their company First Virtual. So in a virtual office, there was no physical office where people met. People were scattered across the country, and they communicated through email on the internet. Now remember, in 1994, this was before the days of GitHub and Skype and Slack. And so it was very hard to run a business this way. And they have an interesting paper outlining some of the challenges of that business model. But anyways, back to what they actually propose. What they propose is a system where both the user and the merchant sign up with First Virtual. They have an account, and then they conduct transactions of electronic payments over email. The idea is that once you put something in your cart and you say, I'd like to check out, what the merchant will do is they'll send an email to transfer@card.com, which is an email address run by First Virtual, and it will have all the details of the transaction. The user is then sent an email with the transaction details asking them to approve it. If the user emails back yes, then First Virtual will bill the credit card of the user, a credit card that the user had provided when they enrolled in the service. Then what will happen is First Virtual will wait to see if the user will dispute the credit card change. The user typically has 90 days to file a dispute. And so First Virtual will ride out these 90 days, and it's only on the 91st day that the merchant actually gets paid the money. This is a major drawback of the system, having to wait that long to receive payment if you're a merchant. However, amazingly, it's not that much different than what happens today. Today, the merchant does get paid immediately. However, there still is the threat that the customer will file a chargeback or dispute the credit card statement. And in this case, the merchant will have to pay the money back to the credit card company. Two other systems to use this architecture are OpenMarket and NetBill. And when you look at these early protocols, what's interesting is to drill down and see at a protocol level what protocols they're using to send transactions back and forth. First Virtual, as mentioned, was based on email. There were other competing approaches. In OpenMarket, it was based on encoding information into the URL. For NetBill, they used a custom MIME type over HTTP. In the mid-90s, there was also a competing approach to the First Virtual intermediary-based architecture. We'll call it the SET architecture. Like the intermediary architecture, it also tries to address the problem of users not sending all of their credit card information to the merchants. It's actually remarkable that no one thought that was a good idea in the 90s. It wasn't until much later that that system became predominant. In this system, it also tried to address the idea of the user having to enroll with the intermediary. So what they decided to pursue is an architecture where the user, once they've settled on the transaction that they want to conduct with the website, they only interact with the website. However, what they do is they take their view of what the transaction details are, and they encode their credit card information, and they encrypt it such that some server, some third party can decrypt it, but the merchant cannot decrypt it. They send it to the merchant, and the merchant takes this information. Since it can't decrypt it, all it can do is blindly forward it onto the third party. However, they also append their own view of what the transaction looks like. Then the third party can decrypt both of these. They can compare the views of the transactions, and if they align, they both say the same thing, then they'll approve the transaction. Now, SET was a standard that was developed by Visa and MasterCard in conjunction with a lot of technology companies at the time: Netscape, Microsoft, VeriSign, RSA. SET was had some intellectual ancestors. There was another company at the time called CyberCash. IBM had a proposal called IKP that was later standardized into a standard called SEP. And Microsoft, working with Visa, had also developed their own standard. All of these use that same architecture that we just described. And so the idea of SET was to unify this architecture, provide a specification where all of these systems would fit under the umbrella of SET. Now, CyberCash, the one company that went into SET, is an interesting company that we'll spend a few minutes looking at. CyberCash had very good relationships with the US government. In addition to their product that was based on credit cards, they also had a coin-based system, a digital cash-based system called CyberCoin. CyberCoin was a micropayment system. So what that meant is that you probably never have more than $10 in your account at any one given time. However, what CyberCash was able to do is they were able to actually get FDIC insurance for each account for up to $100,000. Back in the 90s, when CyberCash was operating, there was also a restriction on the export of cryptography. Cryptography was considered a weapon, and so you couldn't export it to other nations. In this case, CyberCash wanted to export their software. They wanted other people around the world to be able to use it. However, it used encryption technology. So normally this export would not be allowed. However, what CyberCash was able to do is work with the State Department to get a special exemption for their software. And the argument was that going into their software and extracting the encryption technology out of it would be way more work than it would take to just write the crypto from scratch. Also, leading into the year 2000, there was a lot of concern over a bug called the Y2K bug. The Y2K bug didn't turn out to be that big of a deal. There weren't a lot of systems that were influenced or affected by the bug. However, CyberCash has the dubious distinction of being one that was affected by it, and their payment processor software exhibited double payments as a result of this bug. They later went bankrupt in 2001. Their intellectual property was acquired by VeriSign, who then turned around and sold it to PayPal, where it lives today. So let's think about why the SET architecture didn't work. The big problem, probably the fundamental problem of the SET architecture, has to do with a subject of distributing public keys to all the people that need public keys in the protocol. This is called PKI, or public key infrastructure. And a nice way of thinking about this was actually developed by IKP, the IBM project that was one of the predecessors to SET. What IKP did is they came up with 3 levels of security. In the most basic security, only the processor had to have a public key. Now, they had to have more than a public key. This public key had to be bound to their identity in something called a certificate. So we can think of these as certificates. On the second level of security, all the merchants also had to acquire certificates. And in the third level of security, the highest level of security, not only did the processor and all the merchants have to have certificates, but they suggested that all users also have to go and acquire a certificate. Now, these certificates are used so that everybody in the protocol has signing keys. And essentially what happens is every time you do a transaction, everybody signs everything they do. And if there's disputes later, then there's a record of who said what about the transaction. So it's used to keep everybody accountable in the protocol. CyberCash always required level 3, and when the standardization of SET came along, they decided that level 3 was the best level. This is a level where, as I mentioned, all users had to go and acquire certificates. Now, this was a disaster. Users don't want to go and acquire certificates. It's complicated. You have to deal with a certificate authority. In these days, it wasn't an automated process. You would have to send enough information about who you are so that you could be granted the certificates. And so that's a big reason why the SET architecture failed. Some other points of interest about SET. It was, as I mentioned, SET is not a system itself. It's an attempt at standardization. It was done in 1996. Around the same time, another group, the World Wide Web Consortium, were also looking at standardizing financial payments. They took a different approach. They thought it would be interesting to extend HTTP, the protocol, in sort of arbitrary ways. And they had a very general proposal for how you might extend it. And one of the use cases that they had was doing payments. This never happened. Essentially, this was never actually deployed. The whole extension framework was never deployed. And so this was another standardization attempt that failed. At the time that we're recording this lecture in 2015, the W3C has recently came out and said that they would like to do another attempt at standardizing financial systems. And in this case, Bitcoin will be part of that standardization. However, given the past failures, they have a tough hill to climb.